Hi there, I'm Borna, your organic chemistry tutor, and I have another salt synthesis problem for you today. So let's get started. Alright, so this is the problem for today. If you have learned the chapter on carboxylic acid derivatives, you should be able to give it a try. So why don't you pause the video right now, give it a try, and see if you can do it on your own. Now that you're back, let's see if you did it right. Now, let's first of all look at the carbons of the starting material within the product. Now, quite obviously, this diethylamine has ended up here. And then the rest of the carbons of the product, which are 6 by the way, have to have come from this starting material. Now, like looking at it, I'm kind of confused as to how, but let's set that aside for right now. Let's look at the structure of the product and see if it went backwards from the product, what we could get to. So one step before the product would have been this, plus this acid chloride. And the acid chloride, I know, has to have come from the corresponding carboxylic acid. That's fairly straightforward. Now the problem essentially becomes how I could go about making that carboxylic acid. Now, what could I do from the starting material? Given the fact that I'm going from a 6-member ring to a 5-member ring, I'm thinking that I essentially probably have to like break open the ring and close a new ring. And since I have an alkene to begin with, and I have this pattern in the product, meaning one carboxylic acid or one carbonyl and an alpha beta unsaturated double bond adjacent to it, I know that that could be the product of an aldol condensation, and thus I'm going to go ahead, do an ozonolysis on the starting material, get a dialdehyde, and let that do an aldol reaction with itself intramolecularly and see what that'll give me. So if I put this with NaOH and heat it up, the alpha position of one of these, say this one for instance, they are the same so it doesn't matter, can close a ring with this one, closing a 1, 2, 3, 4, 5-member ring, meaning that the product is going to be this, with carbon 1 being here, 5 being here, 4, 3, and 2 being here, and the aldehyde is this one, which looks pretty close to the product. Now, all I have to do right now is to oxidize this using perhaps the Jones oxidant to the corresponding carboxylic acid. So this probably was a good strategy after all. Reacted with SOCl2, create the corresponding acid chloride, and then once I have the acid chloride, all I have to do is to react it with an excess amount of the amine to create the desired product. Alright, that was not that difficult. I hope you liked this video. If you did, please don't forget to hit the like button. That's going to help me a lot. Also, subscribe to my channel to see more solved problems, tips and tricks, and tutorials. And check out my website, as usual, at eurochemtutor.com. See you next time.